Okay, thanks for joining us. We're going to talk very simple stereo center and how to identify it as a R or as a S isomer. Again, remember we in the homework number 4-4.1 we talk about the priority and bond priority. Higher atomic numbers give you a higher priority. So if I look at the Cl, Br, and F in this carbon, first of all, they're all four different bonds: Cl, Br, F, and H. So priority goes with the atomic number. So Cl has the, I'm sorry, Br has the highest priority. Then we go Cl, F, and H. Now we have to go a little bit baby step and we go slowly. I like what Dr. Klein is teaching us and use numbers for the priority. And again, we have to remember priority and numbers are priority, not carbon number for the naming. So if I look at that and do the baby step, so I need to do a baby step. So we have 1 for the Br, 2 for the Cl, 3 for the fluorine, and 4 for the H. And the rule is now, if 4 is away from us, which is this dash means, we ignore it. Now the structure becomes flat because we don't have bonds coming toward us and bond going away from us. So we have a triangle. And then we put the number there. So we put 1, remember 4 is gone, 2 and 3, 2 and 3. We connect them. So this is a counterclockwise. So a simple one. So that means the structure we drew is a S isomer because H is away or 4 is away and the rest are counterclockwise. And eventually we're going to learn how to do this maybe without putting more numbers, without many steps, but at this point I like to try it with the steps, baby steps. Now if I move the Cl and Br, exchange them, see what we get. The numbers are 1, 2, 3, and 4, so it's still 4 away from us. So we ignore it. Now we have 1, 2, 3. Now it's different. It's clockwise. So this would be an R isomer. So this would be an R isomer. So now we learn also that this is structure and this is structure because one is S and R. And they are the same bonds. We have Cl, Br, and F and H. So they are enantiomers. So these two are, we learn, naming wise, they are enantiomers. So now if the H, or number 4 in this case, prior to 4 is not away from us or coming toward us. So if I draw this 4 bonds and put the H here, so now H is in this paper. Cl is coming toward us and F is going away from us. Again, we do the baby steps. We put the numbers there, 1, 2, 3, 4. So the rule and the easy thing to do is to exchange 4 with another number. So we're going to exchange it with 3 here, next to each other. So 4 basically now goes away from us, 3 is on the paper, 2 is coming toward us, and 1 on the paper. Now we can put on the paper. So 4 is gone, right? So this become 1, 2, 3. So it's S. So the catch is, or something we need to remember is if we get an S isomer, the original molecule was the opposite, would be R. So that's really the only thing we need to remember by this exchange. If I get S here, the original was R, and vice versa. So now if I look at a little bit different substitution, different bonds, and let's say the first attachment is all the same. We have carbon, 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 and carbon. So we have to look at the second element. In this carbon is attached to chlorine. This carbon is attached to O. This carbon is attached to nitrogen. This carbon is attached to hydrogen. So we can see now, we can compare Cl to O and to nitrogen and a H. So obviously H gets priority number 4. Nitrogen and oxygen. Oxygen has higher priority. So it would be 2, nitrogen would be 3, chlorine would be 1. Again, baby step, we put numbers 1, 2, 3, 4. Fortunately, 4 is away from us, so we can put it away. 1, 2, 3, R. So original was also R because we didn't change any bond. So this isomer is R. Now if I draw a zigzag structure, and we have only 3 carbons, the name would be R isomer of 3-amino 2-chloromethyl 2-methyl 1-ol. A little bit complicated, but we're going to learn more naming later. So now if we have a double bond, triple bond, a double bond to a carbon, got a little bit not very strong color here, but again a double bond, we count it twice. So it means this carbon carbon double bond is made of carbon 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 carbon. That's what the priority is. Now if I have a triple bond, we count it 3 times. Carbon 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 carbon. Now if you have a carbon double bond O, sorry, we count it twice. So when the carbon oxygen carbon, and we count it again carbon oxygen. Now if I have a carbon triple bond N, we count it 3 times. So it would be carbon, nitrogen, and nitrogen, nitrogen, carbon, carbon. So let's look at an example, make this a little bit smaller. So we're going to look at the carbon that is bonded, carbon, double bond carbon, coming toward us. Carbon, triple bond N and nitrogen group away from us. Carbon, double bond OH on the paper. Carbon, triple bond carbon H on the paper. Again, we remember the oxygen, carbon, oxygen, oxygen, carbon, has the highest priority, 1. Carbon, nitrogen, nitrogen, carbon, carbon, nitrogen, has priority 2. Now we have to decide between these 2. Carbon, 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 carbon 3 times has higher priority than carbon, double bond carbon. So this would be 4. Again, baby step. So you put numbers there. 4, 3, 1, and a 2. 4 is not away from us, so we're exchanging 4 and 2. So we have now ignored the 4. We have a 2, 1, and a 3. If I connect them is a R, again we exchange. So if this is S, the original was R. Always remember that. When we do exchange, we go from R to S or S to R. So this crazy compound, carbon, carbon double bond, carbon, carbon triple bond N, carbon C double bond OH, and triple bond on an alkyne here is a S isomer because what we get was R, so we're going to say to ourselves, okay, so the original was S. Now going to the name, and let's look at the carbon with basically 2 center. Again, please take a baby step. So let's look at this one. That's one of the homework. At C5, I believe. So I I'll only look at one carbon at a time. So if I look at this carbon, at this point, only this carbon, I can see we have a H, that's priority 4. We have a Cl, so that's priority 1. So now we have to decide between these two bonds. This carbon has only H's. This carbon has a bromine. So the bond between this carbon and this carbon takes priority 2. It's not easy to read it, but this is really 2. Then you have a carbon H, so that's priority 3. We got lucky 4 is away from us, so we can ignore it. So again, I might draw my little triangle, 2, 3, and a 1. So if I connect them as R, we didn't exchange, so R is R here. So let's look at this carbon. Again, baby step, 4, 1, 2, and 3, 2, and 3, because this carbon has Cl. So it would be 1, 2, 3, so this is also R. If we put all together, this carbon is R, this carbon is R. I didn't show the priority here. Now I'm showing only carbon number, 6 carbon. Position 3 is R. Position 4 is R, so we write that in parentheses. Then we name the Lewis structure as 3 bromo 4 chlorohexane. But the R and R indicates the stereocenter. Thank you very much.